If we have a liquid that can easily be turned into a gas, or a gas that we want to find more information about, we can use the ideal gas law in order to calculate and determine the molar mass of that gas. So by knowing the temperature and the pressure, the volume, and the mass of the gas, we can find its molar mass. Because we can find the mass in grams, typically in the lab, and we can calculate the moles using the ideal gas law. So here's an example. Calculate the molar mass of a gas. We know that it has 0.311 grams and a volume of 0.225 liters. The temperature is 55 degrees Celsius and 886 millimeters of mercury. So let's do our conversions to get our units into the proper units. So millimeters of mercury need to be converted to atmospheres. So we get 1.1658 atmospheres. We have to convert our temperature into Kelvin, so 55 degrees Celsius plus 273. We get 328 Kelvin. Now we can find the number of moles. So the number of moles is PV divided by RT. We found our pressure in atmospheres. The volume was given in liters, 0.225 liters. R is our ideal gas constant, 0.08206. And our temperature was 328 Kelvin. The number of moles, 9.745 times 10 to the negative 3 moles. So now to find our molar mass, we can take the grams and divide by the moles. We were given grams in the problem. We just calculated moles. We end up with 31.912 grams per mole. Now we might need a little more information to figure out exactly which gas this is, but if we knew it was diatomic, we could use the masses off the periodic table to determine that this potentially could be oxygen based on the mass that we found. Here's a practice for you. See if you can calculate the molar mass of a gas. Pause the video and attempt your calculations. Let's start by converting our pressure. So 3.80 times 10 to the second torr. We have to convert from torr, which is 760 torr in 1 atmosphere. We get 0.5 atmospheres. We also have to convert our temperature. Which is 127 degrees Celsius. We end up with 400 0.15 Kelvin. Our volume is good, so we can solve for the number of moles. We can put in our pressure, the liters from the problem, divided by R, which is our ideal gas constant, 0.08206. Times our temperature, 400 Kelvin. This allows us to find that we have 3 moles of gas. Now to find our molar mass, it's going to be grams divided by moles. So 12 grams divided by 3 moles. Our molar mass is 4 grams per mole. And there really is only one gas that this can be, which is helium.